Hello everyone, welcome back to our channel Lux Physics. In this video, we clear up about the three processes of light in matter interaction that are the basic principles of laser, and these are the building blocks of laser also. So the first point is absorption, second is spontaneous emission, and third one is the stimulated emission. So the first question came in mind, that is what is absorption. So here this is the concept of absorption, where the two energy levels are there. One is ground state energy level E0, and one is the excited state, that is having energy E1. So in the absorption, what is happening there? If one photon having energy h nu, which is incidenting on the ground state atom, that atom absorbing that energy and transit from ground state to the excited state, and this process is called as absorption. Case the photon energy which is incidenting on the ground state atom having a fixed value, h nu is equal to E1 minus E naught. That means whatever the energy provided to the ground state atom, having the energy difference between these two energy levels. So again we will going through the definition. When the external photon having energy h nu is equal to E1 minus E naught collides with an atom in the ground state, it absorbs the energy of photon and jumps to the excited state energy level. Such a type of transition in which the ground state photon absorbs energy and goes to excited state is known as absorption. We will write this absorption is in the form of equation. So here A is our ground state atom, h nu is the photon energy which is incidenting on that atom, and A star is the atom which is in the excited state. We will see here in this figure, this is the ground state atom and photon is incidenting here, which is having energy h nu is equal to E1 minus E naught. After absorbing the energy by the photon, that atom will going or transit into the excited state. So this is all about the absorption. Here we will discuss this point, absorption detail. The next point is spontaneous emission. So question in mind is that what is the spontaneous emission? In the absorption, we will study that atom is in the ground state and that absorbing energy and going into the excited state. So in that case, that atom should be coming into the ground state by whatever the energy that will be consumed by that atom. Consumed by that atom, it will be all absorbed in the spontaneous emission. So here the spontaneous emission is what? When the atom is in the excited state, it is transit from excited state to the ground state here. Excited state to the ground state by emitting a photon having energy h nu. Such a type of emission is called as spontaneous emission. In this case, we have to know about it. Whatever the an atom is going from ground state to the excited, it will de-excite within the 10 to the power minus 8 seconds, and this is this process is happening naturally. So we can call it as a spontaneous means naturally occurring process. Okay, so in this case also we will write this spontaneous emission is in the form of a reaction. So a star is the atom which is already in the excited state. It will transit from excited state to ground state. So the atom A is represented as an atom in the ground state, plus h nu, the energy emitted by the photon, that is having energy h nu. And keep in mind that whatever the energy absorbed by the atom in absorption, same value of energy it will be emitted while in the spontaneous emission, because in the absorption the energy difference between two energy level, the energy level between two energy levels will be energy will be absorbed by the atom, and here in the spontaneous emission whatever the energy difference between these two energy levels it will be emitted here. So, in the spontaneous emission and absorption, these two topics will be covered, and in that same thing is there. One thing, atom absorbing the energy, and in spontaneous emission, atom giving you or emit the energy. The third question, that is stimulated emission. So, stimulated emission can be defined as the process in which photon emitted due to forceful transition of an atom from excited state to the ground state or transition state. So, in this case, we already studied spontaneous emission. The same condition will be here. Atom is already in the excited state, and we have to provide an external energy to this excited atom to transit from higher energy level or excited energy level to ground state. This is called as stimulated emission. But here, whatever the transition is happening in between the excited state and the ground state, it is done due to the forceful transition. Forceful means external extra energy will be provided to the excited state atom to go into the ground state by emitting a two photon. Someone has question like how two photons will become. So keep in mind that whatever the external energy we will provide na, that will only trigger the atom to go into the ground state. That atom does not absorb this energy photon. So this energy photon and whatever the transition between excited state to the ground state, that one photon, so incident photon and emitted photon, both the photons will be now a 2 h nu photon, means two photons will be there in the emission state. So here we will say again, like in the definition form, an external photon having energy h nu is equal to E1 minus E naught collides with an atom which is present in the energy level E1, that means in the excited state. This collision can induce atom to make a downward transition from excited state E1 to ground state E naught. Due to this transition, two photons are emitted. Such a type of transition is called as or is known as a stimulated emission. So we can write this stimulated emission in the form of equation. Atom is in the excited state, so we will write it as a star plus external energy photon h nu, which is incidenting on that excited state. So we will write it here a star plus h nu, which is the initial condition. Then what is the last condition? Atom is transit to the ground state. So it will be write it as A plus two photons are here. So each photon having energy h nu. So h nu plus h nu, it becomes 2 h nu.